Okay, we're going to take a look at emission control components and different systems that were used to control different pollutants coming out of the vehicle. So today we're just going to give you an overview of different components and how they work, brief description. Wanted to show you a few things that I'm going to attach in the module. Here's a map of the United States. And you'll notice on the map, there's areas that are dark with gray areas and darker gray areas and a lot of white areas. This is an example of the testing that they do across the country to check for the clean air to see what the levels of emissions are in different parts of the country. So as you can see over in California, this area here's pretty dark. That means that it requires different added components on the engine to reduce the emissions leaving the vehicle. The Northeast, up in this area, this is probably the second worst area of the country. You can see there's New Jersey here, here's New York. So we have very strict emission laws in that part of the country. Near major cities, down here is where Houston is. Here's Dallas. And of course, San Diego. We have Los Angeles, which is kind of dark right there. And then we have San Francisco area here. Basically, all these areas have higher than normal emission levels or pollutant levels in the air. Notice there's a lot of states in the middle of the country that are very clean. We don't have a lot of indication that we have a lot of pollutants. So there's about 21 states in the country that require people to get their cars inspected. In California, they call it a smog test. In my state where I'm from, in New Jersey, we had emissions testing. So we're going to talk more about that in a future class, but again, every 2 years you have to get your car inspected and make sure that it's passing the emission levels for that model and that year vehicle. States like down through the center here, Nebraska and Florida, very little except in the Tampa area. A lot of these states don't have any emission standards, so they don't have to go to motor vehicle inspection and get your car tested, but 22 states do. So we're going to take a look at some of the different emission components that came out. The first one, there was something called the Clean Air Act, which was way back in the 1960s, and that's when the government started to get involved with dictating to the manufacturers that you have to lower your emissions coming out of the vehicle. The first thing they were focusing on were where are our emissions coming from on the vehicle. So this particular handout here that I'm going to give you has kind of a pie chart on it. And if you look at the different area percentages, exhaust emissions are about 60% of what comes out of the vehicle. Crankcase emissions, which is coming from the crankcase of the engine, which we'll talk about in a few minutes, that's 20% of your emissions. And evaporative emissions are like vapors from the gas tank and raw fuel vapors that are escaping the vehicle, not coming out of the exhaust, but from around the vehicle when it's sitting overnight or sitting outside or even when you're driving. So we have to deal with these three areas: exhaust, crankcase emissions, and evaporative emissions. So this handout kind of gets into some detail about each one of these that we're going to be getting into. Another thing I'd like you to understand are the three major pollutants that are coming out of the vehicle. These are them. We have HCs, which is an abbreviation for hydrocarbons. And hydrocarbons is basically raw, unburned fuel. So when you go to the gas station and you smell that gasoline smell in the air, that is hydrocarbons. That's raw fuel vapors that you're smelling. The gas stations are actually supposed to have a recovery system on their nozzles to suck that vapor back into their equipment as it's putting gas in the cars. Some states don't have that. Some states, I don't think it works right, so you'll smell some vapors as you're filling your gas tank up. Another pollutant that comes out of the vehicle is carbon monoxide, and I think you've heard of that before. That's a deadly, odorless, colorless gas that comes out of the vehicle that is bad for the environment, carbon monoxide. And then the third pollutant is called oxides of nitrogen. They abbreviated NOx. And NOx is basically created when you try to reduce these two. When you try to lower HC and CO, we're trying to lean out the mixture by reducing the amount of fuel that's burning. In a lot of cases, if you lean it out too much, you make the exhaust hotter, or the fuel-air mixture hotter, because you're leaning the mixture out. And once it gets over 2,500 degrees in the combustion chamber, you can actually start creating this new gas, which is oxides of nitrogen, which is also bad for the environment. So these are the three things that they're actually looking for when you go to motor vehicle inspection, when they're doing emissions testing. So again, our components that we're going to look at are things that try to control these three and keep them from getting excessive. All right, so the first component that we're going to discuss is the PCV system. Right here you can see I have a handout here that's going to talk about how it works, and we're going to give you like little details on this. PCV stands for positive crankcase ventilation. Positive crankcase ventilation. So basically what we're going to do, we're going to use a few components. I have a few sitting on the table here. These are what they call PCV valves, these little things here. Each one basically has a different manufacturer, different designs. This one here has two fittings on it. When you go to the store or order it online, you have to specify what year, make, and model that you need this component for, because they're different. There's probably about 50 different part numbers for these things. So you have to get the right one. But they all work the same way. It's basically how do they hook up is what you need to be aware of. Some of them have two hoses going to them, and some of them have a straight hose, some have an angled hose. So other than that, internally, this part of it works the same. It's just the hookup that's different. So what does it do? Very briefly, and we're going to get into some more detail. So when your engine is running, some of the combustion gases get past the rings in the engine, past the pistons. And if some of the combustion gets past the rings, where's it going to go? Well, below the rings and where the pistons are is the crankcase. That's where your oil sits. And what happens is the oil area where the oil sits will actually build up pressure from the excess blow-by. They call it blow-by, which is combustion getting past the rings. Now, if you remember way back when we did leak down tests, engines aren't 100% efficient. Some pressure gets past the rings. Maybe 10 to 20, sometimes as high as 40% is still within the acceptable limits. So if you have a newer car, you might have 5 to 10% blow-by gases getting by the rings. That's going to build pressure up in the crankcase. So what we need to do is vent it somehow. We have to get those pressure out of the crankcase. If we don't do that, it's going to cause leaks of oil all over the place. Any rubber seal that you have on your crankshaft, pulley, or your rear main seal where your flywheel is, you're going to have a leak coming out of there because the pressure is going to build up in the crankcase. So what they did before 1963 is they just put a vent pipe off the side of the engine block that went down to the ground out the side of the engine, and that basically was called a draft tube. And what that did was it just let the excess pressure out of that tube and kind of hit the ground. And if you look at old pictures of highways, you can actually see a lot of highways were concrete back then, not paved black, they were white. and you'd see a line of like what looked like an oil slick down the highway where cars drove, because parts of the fuel, the oil would come out of that draft pipe and just hit the road, and it would just kind of get all over the place. So the government looked at that and said, that's not acceptable. We need to capture that pressure that's leaving the crankcase out of that tube. So we need you to seal up that tube. And what they created was the positive crankcase ventilation system, which is actually involving this little valve right here. This is actually, if you listen, you can hear it rattling because there's actually a little check valve inside here. Basically, this is going to be stuck in one of your valve covers or somewhere where it can pick up the crankcase, either at the top of the valve cover, or it could be in the middle of your intake manifold, not in the part where the air and fuel go in, but where it can go down where the crankcase is. And it's going to allow gases that are in the crankcase to pull through this valve. This end of the valve is hooked to your intake manifold vacuum. So when your engine's running, it's going to create a pretty strong suction on the valve, almost 17 to 21 inches of vacuum at idle. And basically it's going to suck all the vapors out of the crankcase. And where do they go? They actually get sucked back into the intake manifold and reburned. So they're kind of recirculating the gases that are getting by the piston rings. Now, the reason they have a little valve in here is every once in a while your engine might backfire. If you ever hear your engine pop when you're driving, that pop is actually a flame that's reversing through and trying to get out the intake. Now, your air cleaner or air filter is supposed to capture that, but it's also going to try to get down into the crankcase through this hose that your PCV system is hooked up to. So this has like a little check valve inside it, which you can hear it rattling in there. You can hear that one. That little check valve is supposed to seal up immediately if there's a backfire, so the fire can't get down in through this valve and into the crankcase, which will actually cause an explosion because you got basically raw fuel sitting in your crankcase. So PCV valves are designed to be like a one-way check valve to keep the fire that might happen when a backfire occurs from going into the crankcase and causing a problem. The other problem with these is they get clogged up. If somebody doesn't change their oil regularly, these get all gummed up inside here. So what I usually do is take it off and rattle it and see if it makes noise, which is an indication that it's free. You can actually clean these with some carburetor cleaner. They're pretty inexpensive. They're about $5, maybe $5 to $8. So recommendation is if it's clogged, you should replace it with a new one. Now, in order to suck the vapors out of the crankcase, you need to let fresh air into your engine on the other side. So usually this might be mounted in one of the valve covers on a V8 or a V6 engine. And then the other valve cover might have something that looks like this. This is basically a fresh air intake side. So we're going to have fresh air. This is usually hooked to the air cleaner with a hose, so you get filtered air. This is going to allow filtered fresh air go into one side of the engine, while this is sucking the vapors out of the other side of the engine into the intake manifold and reburning them. So that's basically what a PCV system does. Is it positively sucks all the vapors out and reburns them again. All right, so that came out in 1963. That was when this system appeared, and they're still using it today on cars to ventilate the crankcase. There are some that don't have it. They do it a little differently, but I would say 80% of the cars have this PCV valve on the vehicle. All right, so 1963 was the beginning of the government being involved with different emission controls to try to lower some of the pollutants. All right, next thing we had in the 1960s also is there was a lot of concern about the exhaust gases leaving the engine and being not completely burned. So you would actually have some high emissions coming out the exhaust manifolds. And what they required on some vehicles back in the mid-60s was an air pump. This is an example of what an air pump looks like. This would have a pulley on it, and this pulley would spin this like an alternator, basically spins the inside of this. And this is actually just a pump. This pumps air. And they would have a tube coming out of here with a fitting that would go back into your exhaust manifolds. There would be pipes that went into your manifold, and what that would do is pump fresh air into your exhaust manifold, and the purpose of that was to continue the burning process when the exhaust left the engine, because when a car is running rich and there's no more oxygen left, you're going to basically run raw fuel and different gases out the exhaust manifold. What they found is if they pump air into that, you can continue the burning process further, and that will cause what comes out of the tailpipe will be a lower level of emissions. It'll continue the burning process as it travels through your exhaust system and cause it to run cleaner. So back in the 60s, they had a belt-driven air pump. Most vehicles, if they were sold in certain parts of the country, such as California or the Northeast, might require an air pump, but if they were going to ship the car to like the middle of the country, let's say Nebraska, that same car, because it was shipped to a dealer in the middle of the country where they didn't have emission concerns, it might be the same engine without an air pump. So depending on where the car was originally or truck was originally shipped determines what type of emission controls were put on that vehicle. So they used mechanical driven, belt driven air pumps for a long time. Then they switched to electric air pumps. This is an example of an electric air pump. The difference now is instead of taking some power away from your engine, because a lot of people back in the 60s, they looked at this as a device that robbed horsepower. First thing, they would go along and cut the belt off. This had its own belt that ran this pulley, not the belt for the alternator or the water pump. It basically had a separate belt just for the air pump. They would cut that off because this would rob like 10 horsepower of your engine. They wanted to get all the horsepower they could. And actually some bigger engines, like big block V8s, might have two air pumps, one on each side of the engine, one pumping air into one side of the exhaust and the other one pumping air into the other side of the exhaust. So I've seen big trucks with big engines having two air pumps in them to get reduce the emissions. The electric air pump is good because it takes very little power from the engine to run these things. And basically it'll run when you first start up your car, when your car is cold, and we have to warm it up quick and get the emissions low. When it's cold, it usually runs a lot richer when it's cold. So this air pump might only be required to run initially when you first start up the car, when it's in open loop. If you remember, we talked about open and closed loop. Once the engine reaches operating temperature and your oxygen sensor is doing its thing, we're in closed loop. And this computer can now signal the air pump to shut off because it doesn't really need it anymore. It only needs it when it's cold, and it's there for two purposes: lower emissions and also to warm up your catalytic converter. By pumping air into the exhaust, you're actually heating up the exhaust quicker because you're putting oxygen into the fire, and you're going to actually get the catalytic converter to start working quicker. So we'll talk about a catalytic converter in a minute. I grabbed this. I've had this for years and years and years, this funky looking thing here. This is what I used to call the poor man's air pump. It basically wasn't a pump at all. It was basically just this chamber and these pipes here which screw into the exhaust manifold, and each one would go in. This is off of 4 cylinders, so you'd have 4 pipes going into each, where each pipe came out of the engine. It had these like little check valves inside here. And as the engine ran, these check valves would let fresh air in through here, in through this box, and then suck into the exhaust manifold. So instead of using a pump that actually pushed the air in, it would actually just suck the air in by having the exhaust pass by the ends of these tubes, and it would suck air in. So this was used like in the 80s, 1980s, and I think the late 70s. So that's another type of thing. These would rust away and leak, and you'd have to replace them. All right, so this came out in the 1960s to try to lower our emissions. They're still using air pumps today, so we still have cars with air pumps on them to try to reduce emissions, especially in California and other states. Okay, then starting in 1970s, the early 70s, 71, we were concerned about the emissions coming out of the gas tank. If you notice when you open up a tank of gas, you'll see vapors coming out, or you can smell it. Like if you take your gas cap off, you can smell vapors coming out. So before 1971, we used a vented gas cap. The gas cap itself had a hole in it to let the excess pressure in your gas tank go up through the gas cap and vent into the air. Now that is pure hydrocarbons. Basically, it's like leaving the gas lid off your gas cap, your gas tank, and just letting the vapors come out into the air. And before 1971, that's how they did it. The gas tank has to be able to breathe, because when it gets hot outside, pressure builds up in your gas tank. You can actually hear it when you take the gas cap off. When you're filling your gas, you can hear like a sound. That's actually the pressure releasing out of the gas tank when you take your gas cap off in some cases. So that was not good, because if you think about it, if we have a hole in the gas cap, that's going to basically let raw vapors, which is hydrocarbons, into the air. So the government required, starting in the 70s, a way to capture those vapors. So what we used is a Evap system. Evap is evaporative emissions. Evaporative means vapors from the fuel system, we have to capture them somehow, so we don't let them out in the air. So the first earliest ones were these charcoal canisters. Somewhere on your vehicle, usually under the hood, you'll find this canister, and it's actually filled with charcoal, like little pieces of charcoal with a filter on the bottom. And what charcoal has the ability to do is to absorb vapors from the fuel system and collect them inside here. Now, what we did was, when the car was parked and you weren't driving anymore, it would actually just collect all the excess pressure and vapors and store it inside this container. And then one of these hoses on here went to your gas tank. Actually, it's marked so you can actually see. This one says fuel tank. This one says carburetor bowl, which we'll talk about in a minute. And this had something to do with controlling it. But basically, this went to your gas tank with a hose, and then this one went back to usually the intake manifold, or in this case, it went back to the bottom of the carburetor. And what happened when you start the car up in the morning, all the vapors that are collected in here would suck out through the hose, which was hooked to your intake manifold. You'd have a lot of vacuum there, and it would suck all the vapors out and reburn them. So instead of sending all those vapors into the air, we would put them into this canister temporarily and then reburn them to save the environment, basically. We're basically not putting it in the air. So over the years, it evolved into something that looks like this. This is another design, basically looks similar. So through 1996, we had this type of Evap system that basically just collected vapors and reburned them. The only problem with this system is if something went wrong with this, let's say the hose fell off or got a crack in it, it wasn't working anymore. I've seen these crack when people have accidents, they break these things. These are usually under the hood somewhere, so if you hit something, you might damage this. There was no indication to the driver that there was a problem with your Evap system. Basically, the only thing you might notice is if you park your car in the garage and you close the door and you come out in the morning, get into your car and you smell in the garage and it smells like raw fuel, that is because your Evap system's not working properly. It's basically not collecting the vapors, it's letting it into the air, and you can actually smell it. It's like you poured gasoline on the floor and you can smell a lot of raw fuel vapors. So that would be the only indication that maybe there was something wrong, or maybe it's leaking fuel. There might be fuel dripping out of the bottom of it if something's wrong with it. All right, so 1996 was a big year. 1996, they changed a lot of the requirements of the manufacturers. It's called OBD2. OBD2 is Onboard Diagnostics Generation 2. Part of that change was to have what they call the enhanced Evap system. This is what the charcoal canister looks like now. It's got this funky looking valve thing on it, and some of them are square shaped, some are rectangular shaped. Here's one off a Toyota. Looks a little different. Basically, it still stores the vapors inside here, like these older ones. But the difference is this monitors itself. This actually can tell if it's working properly by testing it as you're driving, and to see if there's any cracks or leaks or anything inside the system. If there's any leaks within 0.020, that's 20 thousandths of like a little pinhole somewhere in one of these pipes, it's going to set a code. It's so sensitive that if you leave your gas cap loose, that's a leak as far as it's concerned. It'll actually set a code for a loose gas cap, which is indication that you have an Evap leak. So this is what they call the enhanced Evap system. We're going to get into a little about how to test this. Sometimes it can be really hard to pinpoint where the leak is because you might have a pinhole somewhere. So the easiest way to do it, I found, is to use smoke. You're actually going to seal up all the valves and everything. You have to kind of go through a procedure, and then you're going to pump smoke into a special fitting, which they have on the vehicle. I can show you what that looks like. It actually has a green cap on it, and that cap allows you to hook your smoke machine and testing equipment up to your vehicle. And you have to use a scanner because you actually have to close the valves at the right time, pump smoke in, and then basically you're just visually looking around for where the smoke is coming out, and that would tell you where your leak is. So sometimes these get cracks in them. I've seen problems with the hoses. I've seen problems with the solenoids that activate the Evap system. All right, so this came out in the 70s. These older ones are 71. These are 96. So again, these are for evaporative emissions. 1973 was another big year because we needed to control another emission. So what we had back in 1973, this emission here, which is oxides of nitrogen, they found that this was being created because they were trying to reduce these two, HC and CO. By leaning out the mixture so much in the 70s, they actually created a lot of heat in the combustion chamber, which was causing temperatures to exceed 2,500 degrees. Once you get over 2,500 degrees in the combustion chamber, you're actually going to start combining the nitrogen that's in the air. Air is made up of about 21% oxygen and about 78% nitrogen. You're actually going to create this new pollutant called oxides of nitrogen when the heat gets up to 2,500 degrees, and that's going to cause a pollutant that actually creates acid rain, and it also creates smog. So like if you ever go to Los Angeles when they have a lot of smog in the air, that's from oxides of nitrogen escaping into the air. That can cause smog, and acid rain is when it rains through that smog, it actually creates an acidy rain. So what they came up with was a way to reduce the temperatures of the combustion chamber down below 2,500 degrees. So the way they did that was this component right here is called an EGR valve. EGR stands for exhaust gas recirculation. Now the older ones, this is from the 1970s, this EGR valve is pretty old. These were vacuum controlled. They had like a little vacuum hose on here that went to your intake manifold. Now, we have to control the EGR valve only when we're not idling. So like you don't want the EGR valve to have vacuum going to it when it's idling, and I'll explain why in a minute. So we need to route the hose to something that doesn't have vacuum until we're off idle. Now, in some cases, they actually use an electronic solenoid. This is what we call a Evap solenoid, or not an Evap solenoid, an EGR solenoid. This would actually control the vacuum going through it. So at idle, it wouldn't let any vacuum. Even though you had vacuum going to one side, it wouldn't let any vacuum come out of the other side. until you started driving the vehicle, and then the computer would start pulsing this solenoid on and off, letting some vacuum go through. Once the vacuum got through, it would go to this valve and to this fitting, and it actually would do this to it. If you watch the end of this, see how it opens up when I do that? I'm actually pushing down on this part, which is the diaphragm. So when you put vacuum on the EGR valve, it's gonna suck the thing open. Now what this does when it opens up is it takes some of the exhaust in your exhaust gases and recirculates them into your intake manifold. So let's think about that for a second. We're gonna take exhaust gases and recirculate that into the intake manifold. Now what will that do? Well, by putting exhaust into the intake, regulating a little exhaust in there, because exhaust doesn't have much oxygen in it, and the way heat happens in a fire is you have to add oxygen. If you want to lower the temperature or something, you have to take away oxygen. So what this valve did was it actually removed oxygen from the intake manifold before it got into your combustion chamber, and it would actually lower the temperature of the combustion chamber, which actually would reduce NOx, because NOx is only created when you have over 2,500 degrees. So the older EGR valves were vacuum controlled. Basically, it either opened or closed. Basically, it could pulse a little here and there and regulate how much exhaust gases go in. Problem is, if you have EGR at idle, let's say I open this valve up at idle, the engine's running at such a low speed, it'll almost stall the engine, because the engine basically doesn't like the exhaust gases going in. It's basically diluting the oxygen. Engines like oxygen. So that's why we never put an EGR on when we're idling. So this valve here, this solenoid will prevent that from happening. Now, as years went on, this was back in 1973, in the later 70s, 80s, different types of EGR valves. These are what they call positive and negative back pressure EGR valves. Different designs, worked a little differently, still had a vacuum hose going to it. You had to make sure you ordered the right EGR valve. So depending on the year, make, and model, when you're buying an EGR valve, you need to make sure you get the right design. This is just a vacuum EGR, just a regular ported vacuum EGR valve. These here are, one's a negative back pressure. If you look at the part number, there's an N. After that 32, that means negative. This is a negative back pressure. You can also tell by looking at the diaphragm. If you look inside that silver thing, see how it has a bump in the middle? This one here is flat. There's no bump. This is just a ported vacuum EGR valve. This one here also has a bump, but if you compare the height of that bump to the height of this bump, this one's taller. This is a negative, and this is what we call a positive back pressure EGR valve. So again, different designs for different year and make, model, and engines. Make sure you get the right one. They have different part numbers for different year, make, and model. Here's another EGR valve. Again, vacuum controlled. It's got the flat diaphragm. This is a ported vacuum EGR valve. And here's another one here. Just a different design, same kind of setup. Can't see the diaphragm on it. But this would actually, again, pump air, exhaust gases into your intake, which would reduce the combustion temperatures. Now, they got kind of fancy with EGR valves. Here's a really funky one. I remember in the 80s, this thing came out. This is a 3 solenoid EGR valve. It's not vacuum controlled anymore. They didn't like vacuum. They were trying to get away from vacuum. They went to a fully electronic EGR valve. So what they decided to do is, let's set up 3 solenoids here that can open and close when commanded. Each one has a porthole underneath. One has a small hole, one has a medium hole, and one has a larger hole. And what we can do is we can energize these in different sequences. So if we want a little amount of exhaust gas recirculation, we'll just open up this one. We'll get like 20%. If we open up these two together, let's say this one does 30 and this one does 20, we're gonna get, let's say we want just 30. So we'll close this one, we'll open this one up. So this is gonna be 30% EGR. Let's say we want 50%. What we can do is open these two together, and that's gonna create 50%. If we want, let's say 70%, we can do this one and this one, which would be 50 plus 20, that's 70%. If we want 100%, or no, let's say we want just 50%, we can just do this one. Or let's say we want 100%, we'll open all three up. So we can get 100% EGR flow. So the computer could do different combinations of flow by energizing different solenoids and different sequences, which will cause a different amount of flow rate through this EGR valve. Okay, so this is what we had for a while. Most of the newer cars now have something that looks like this. This is a solenoid-controlled EGR valve that has no limitations. It can open and close. Let's find one here that actually opens. Let's see. Okay. So basically what we have here is the opening. The solenoid, which is this part of the EGR valve, it has infinite positions. So if I take something and stick it inside here, you can see how it kind of works. If I push down on this middle part right here, you can see that that opens and closes. Now what the computer can do with this one is it can do like 10%. So if it puts 10% on and 90% off, it'll open it up just 10% of the opening. If it wants 50%, it'll pulse it on 50% of the time, and 50% off, it'll open it halfway. If it wants more, it can pulse it 70% on, 30% off, it'll open it up a little more. If it wants a lot of exhaust circulation, it can do 100% on and 0% off, and it's wide open then. So this little valve here that can go anywhere from 0 to 100% is controlled by the computer to very accurately put the amount of exhaust into the intake that we need for the driving conditions that you're driving. So again, this is controlled by this little plunger here, controlled by the computer. Okay, so this is the newer type of EGR valves that don't have any limitations to positions. They can basically do whatever they want as far as controlling the emissions. So we're still using these on newer vehicles to control NOx, again, oxides of nitrogen. All right, so this was, we had another big thing that happened in the 1970s also. Here's some information in your module about catalytic converters. So catalytic converters were put into the exhaust system starting in the mid-70s to control both NOx, HC, and CO. So basically it was doing all three emissions. You can see what we have going on here. So we have coming in is HC, we have CO and NOx coming in. We took either older ones had beads in it that had coatings of different material, platinum, palladium, rhodium. These are rare elements. That's why people like stealing catalytic converters, because if you get one, they'll give you some money for it because there's elements in there that can be melted out and be taken out of the catalytic converter, and they're worth money. Platinum's expensive, palladium and rhodium is expensive. But the idea is these rare elements, these expensive elements, react to the hot exhaust entering the catalytic converter, and it actually has a reaction, and what comes out of the other end is like a miracle here. We go in as bad gases here, HC, CO, and NOx, and we actually come out as water vapor, H2O, which if you ever see a car running, sometimes you see water dripping out of the tailpipe. That's normal. We also have CO2, which is carbon dioxide, which isn't a poisonous gas. It isn't good for our environment because it can cause greenhouse effect. And then we have N2, which is nitrogen. Nitrogen is good. The plants like nitrogen. They actually breathe it in, and they like that stuff. So catalytic converters are like a miracle device that can actually change drastically your emissions when it goes through and reacts to these elements inside here and comes out as a cleaner gas. So starting in the 70s, we started using catalytic converters. I just wanted to go underneath the vehicle real quick and show you these. Put my truck up in the air so we can get under there just to see. Depending on what engine you have, you might have more than one catalytic converter. You look right up here, see this piece right here? This is your catalytic converter coming off the engine. There's a pipe coming out. And then on the other side, if we come over here, there's another catalytic converter. So you have two of them, one on each side of the engine. There's actually a component, if you look there, it's screwed into the back of the catalytic converter with a wire coming out. That's an oxygen sensor. It's actually monitoring the catalytic converter to see if it's working properly. There's an oxygen sensor up front too. You can't really see it, but it's up there somewhere. Let's go over to another vehicle and look at what its catalytic converter looks like. So this is off one of our donated cars. Here's the exhaust system. So this one has pretty crazy exhaust. You got this, so you got a Y pipe here that kind of comes from each side of the engine. Goes into one pipe. This is a catalytic converter here. They got a second catalytic converter. And it looks like they got a third catalytic converter. So each of these are reducing the emissions as it travels through it to lower it as it comes through. And by the time it gets back here, there's your muffler and tailpipe. So again, catalytic converters came out in the 1970s. It's illegal to take them off. They do take some power away from the engine. You can buy high efficiency flow catalytic converters, which still work, but they flow better. So there are options that you can buy. All right, so I just wanted to show you these. These are still used all the way to today. Okay, so that's basically an overview of our emission control devices.